So we're revisiting our sandwich shop from before, and now the sandwich that they produce sells 10,000 the first month, but now they're selling 20% less each month. So we're going to figure out how much they sell after 1 year, and we want to figure out the total number of sandwiches they sell over time if this trend continues. Now we know to do any individual term in a geometric sequence, we can use the following formula. Now if we wanted to find any particular month for this scenario, we could do 10,000. Our common ratio now is 0.8 because remember it's decreasing by 20%. That means 80% is left to the n minus 1. Now we're not looking for any given month. We're looking for the sum of the first 12 months. So we can use this formula that we used last time. S sub n equals the first term, which is 10, representing 10,000, times 1 minus r to the n over 1 minus r. So we would get this formula. So now we can do the first n months for our new sandwich that's actually decreasing instead of increasing sales. So if we do the first 12 months, we get about 46.564, which again we have to convert into thousands, or 46,564 sandwiches. That's exactly what we were doing last time because that's the sum of a finite geometric series. Now we're going to extend this a bit further and look at the sum of an infinite geometric series. So what happens as this continues over time? So we're going to set up our formula again. So we have S sub n equals 10 times 1 minus 0.8 to the n over 1 minus 0.8. What we're going to do is plug this into the calculator and see what's happening graphically. So here's our graphing calculator, and here's how we can put our function in. So this will calculate the sum for month X, and if we go in a standard window, we don't see a whole lot. All we see is that it's increasing. Well, it should be increasing because even though each month we're selling less sandwiches, they're always going to be adding on to the total. Now we want to see what's going to happen over time. So let's go to our window and see what we can do. Well, let's make this a little longer than 10 months. We'll do the first 30 months of this sandwich. And we know that in month 12 we had about 46,000 sandwiches. So we need this Y max to be a little higher than 10. Well, let's do 60. Now let's take a look at the graph. Notice what's happening. It's increasing at a decreasing rate. It's concave down. Notice how level it's getting. There's a chance we might have a horizontal asymptote. Remember what our question was, to see how many sandwiches total we would sell over time. The output of this graph gives us the number of sandwiches we're selling. So if it levels off, we can get a total number of sandwiches over time. In other words, we can get a sum to our infinite geometric series. Well, let's see, let's make this window, let's go a little further in the x's and see if that changes anything. So let's double it. So we'll look at the first 5 years. Going back to our graph, it gets very flat. Another thing that might be worth looking at in this situation is our table. So what's going to happen as our inputs go up? We know they're going to go up and they're going to increase at a decreasing rate. In fact, we can already see how slowly they're starting to go up now. And they're going up slower and slower. Let's just skip ahead a little. And now we're just repeatedly getting 50, 50, 50. Now remember what this function does. It takes a number of months as an input and gives the sum of the total up to that month. Starting at month 1 up to whatever month X is, it gives the total sum. Notice the sum has stopped increasing. So whether we're looking at month 56 or month 60, our total number of sandwiches is 50,000. Let's go back and see why this is happening. So in our formula, if we look at this piece here, this is actually exponential. Not only is it exponential, it's exponential with a base less than 1. So as n goes to infinity, this piece actually goes to 0. it actually disappears. And our formula simplifies quite a bit. So it turns out that the sum is just 10 over 1 minus 0.8, which if we calculate is 50, or changing it back into thousands, 50,000 sandwiches. So when we have an infinite geometric series, if we're able to calculate its sum, we only need two pieces of information. We need the first term and the common ratio. Now this is only going to work if that exponential piece goes away. Remember, with exponential functions, that base has to be less than 1 for it to be decaying. So we need to follow that, and what we need is the common ratio to be in between -1 and 1. It's okay if it's negative 0.8. That would still go to 0, which would allow us to calculate the infinite sum. So we say it converges if the common ratio is between -1 and 1. Otherwise we say it diverges. If it converges, we can use the formula we have here in order to calculate the sum of the infinite geometric series.